Hello everyone, this is Babitha, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering. In this session, I am going to discuss about the problems on common collector configuration of the bipolar junction transistor. So what are the parameters we are going to calculate in this problems of amplifier circuit? Here it is. The first thing, we are calculating the input impedance of the amplifier in common collector configuration and the calculation of the voltage gain and the output admittance as well as output impedance and the overall voltage gain, overall current gain as well as overall power gain of the amplifier circuit in the case of a common collector configuration. So here, in order to find the parameters of the amplifier in any configuration, first of all we have to go for the AC analysis of that particular amplifier circuit. Because if we go with the AC analysis only, we can able to find the parameters of the amplifier here. So in the case of AC analysis, to do the AC analysis of particular amplifier circuit, we have to take the actual circuit diagram of that amplifier that may be in any configuration, common base or common emitter or common collector configuration. But now we are discussing about the common collector configuration. So that's why I'm taking the circuit of common collector configuration here. So in the case of common collector configuration, the collector terminal acts like a common between both the base as well as the emitter terminals of the transistor. Okay, so the base acts like an input as well as emitter acts like an output in the case of common collector configuration. So here we will add different resistances, input resistance as well as source resistance, and here we will provide the input signal for the circuit, and this input signal through the capacitor we are connecting to the input of the common collector amplifier. So here it is the RS and here it is the RA. And similarly, here we may have the emitter resistance or the output resistance. In some cases, we also have the load resistance RL also. So here we will measure the output V0 here. So this is C0. That is also a coupling capacitor. Okay. So this is the normal actual circuit diagram of the CC amplifier, common collector amplifier here. So this is our first step. And next, replace coupling capacitors as well as emitter bypass capacitor by short circuit. Though we are moving for the AC analysis here, so in the AC analysis, there is nothing but the frequency is low here. So whenever the frequency is low means the capacitor acts like a short circuit. Why it is acts like a short circuit for low frequencies means, for low frequencies the reactance of the capacitor is very high. So that's why it acts like a short circuit here. So we are replacing this coupling capacitor Ci as well as C0 as the short circuit here. And if we are having any emitter bypass capacitor, in some cases it may present or it may not present. If it is present, we have to make this one also short circuit. Okay. And next, replace DC sources by a short circuit. So here we will provide the supply voltage. So this one also we have to make it as ground here. Why? Because it is the DC source, but we are going for the AC analysis. So that's why we are making it as DC source 0 or ground here. And after that we have to mark the terminals of the transistor, that is emitter, base and collectors on the circuit diagram, and locate these points in order to draw the equivalent circuit of the transistor. And next, replace the particular this transistor with its hybrid equivalent model. Okay, hybrid equivalent model or H parameter model. So here this transistor, if I am representing it with the hybrid equivalent circuit means, so in the common collector is the common terminal, and here we are having the base as well as emitter. So this, what are the elements which are connected to base acts like input elements, and what are the elements which are connected to the emitter acts like a output elements here. So for the base terminal, we are having the input resistance HIB here. It is, sorry, very sorry, it is HIC, why? Because it is the common collector configuration. And here we are also having HRC VEC, reverse voltage gain. And similarly across the output side, we are having the current gain HFC into input current, here it is IB. Okay, and along with this, we are also having the output admittance. So this is the equivalent H parameter model for only this transistor, and along with this, we are also having the remaining elements here. These remaining elements, as it is, we have to place across the input as well as output of this particular circuit. So along with this, here we are having the input resistance as well as the source resistance and input signal Vs or Vi. Okay, and across the output side, we are having the resistance Re as well as the load resistance Rn, and here we'll measure the output voltage V0, and we can also call it as VEC. The voltage between the emitter and collector terminals are nothing but the output voltage. And here the output current is the emitter current and the input current is the base current. And the input voltage is VBC here. Input voltage is between collector and base terminals. So that is VCB or VBC, we can represent it any way. So in order to find the parameters of the any amplifier in any configuration, we have to draw the equivalent circuit in this way, and from this circuit we have to find all the parameters. So here we are having three configurations: CE, CB as well as CC configurations. So here I am giving the formulas for the common emitter configuration hybrid parameter. The amplifier parameters in terms of H parameters I am giving in CE configuration. And to find the same parameters in the common collector configuration, we have to take the conversion formulas from common collector to common emitter, or else we are already having common emitter configuration. So these formulas in terms of common collector we need to write here. So for that purpose, I have given all the parameter formulas in the common emitter configuration. This A is nothing but the current gain, that is minus HFE by 1 plus HOE into RA. And the input resistance is HIE, input impedance, plus HRE for reverse voltage gain into current gain into load resistance. Or else if we substitute this AI value, we will get this particular formula. We can utilize either this one or this one to find the input impedance of the transistor. Or else if you wanted to find the overall input impedance, that is the parallel combination of the input resistance as well as the base resistance of the transistor. And next, voltage gain. So voltage gain we can calculate from the current gain as well as load resistance and input resistance. And the output resistance we can calculate from the source and input impedances as well as the variation of all the H parameters. And also along with these particular formulas, we also required the H parameter values of CC configuration here. Why? Because we are going to do the problems related to the common collector configuration. So we have to remember all these formulas. The input impedance is 1100 ohms, reverse voltage gain is 1, forward current gain is minus 51, and the output admittance is 25 microamperes per ohms. So I have already mentioned, whenever we wanted to calculate the parameters in the common collector configuration, we require here conversion formulas of common emitter H parameters into common collector H parameters. Okay, So these all are the common collector H parameters. These common collector H parameters in terms of common emitter parameters we are writing here. So this is the common collector parameters and these are the common emitter parameters. So here the input impedance in the common collector as well as in the common emitter same, it is HIE only. So the reverse voltage gain is 1 minus HRE. So almost it is equal to 1. Why? Because HRE value is almost it is less than 1. Why? Because forward voltage gain means this is output voltage by input voltage. But here we are taking the reverse voltage. Reverse voltage means VI by V0 here. So when we perform VI by V0 means here this is the input signal, V0 is the amplified version of this input signal. So always V0 is higher than VI here. So because of that reason, this ratio we will get it as very less and it is almost less than 1 here. So that's why we can approximate this value as 1 here. And next, forward current gain is minus of 1 plus HFE here. And output admittance is similar to output admittance of the common emitter configuration. See here, the input impedance as well as output admittance are same, but only the gain values are varying in one configuration to another configuration. So these conversion formulas are very important and these are required to solve the problems in the common collector configuration. So welcoming to the problems. The first problem here it is a common collector circuit. So the given circuit is the common collector circuit, has the following components. It is R1 resistance is 27 kilo ohms, R2 is 27 kilo ohms, and the emitter resistance is 5.6 kilo ohms, and the load resistance value is 47 kilo ohms, and the source resistance is 600 ohms. So the transistor H parameters are HI equal to 1 kilo ohm, HFE, HOE as well as HRE is not given. So we need to determine the current gain, input impedance, output impedance as well as voltage gain here. So for this circuit, I'm writing the given parameters. So from these given parameters, we need to draw the common collector circuit now. It is 27 kilo ohms. R2 is also 27 kilo ohms. And the emitter resistance is 5.6 kilo ohms. And the load resistance value is 47 kilo ohms. And the source resistance value is 600 ohms. And the H parameters are 1 kilo ohm. Forward current gain is 85. And the output admittance is 2 microamps per ohms. So from this, we need to find the current gain, voltage gain, as well as input impedance and output impedance. So to find or to solve this problem, first of all, I am drawing the common collector circuit by utilizing this given parameters. This is the base, collector and emitter terminals, and the two resistances are given R1, R2. So I am keeping the two resistances first. So this is R1, this is R2, and here we are providing the input signal Vs. Okay. And this is R1, this is Rs. Sorry. So this R1, R2 acts like a potential divider circuit for the common collector configuration in order to provide the proper biasing required for the amplification. And the emitter resistance also given Re. And the load resistance is here. Why? Because we'll measure the output across the emitter terminal here. Okay. So this is the common collector circuit or amplifier. So in order to find the parameters of this one, we have to draw the AC equivalent circuit or H parameter equivalent circuit for this given amplifier. So for that purpose, I am taking the 3 terminals of the common collector configuration, that is base, emitter and collector. So for the base, the input impedance HIC is connected, and here HRC VCE is connected, and here it is HFC into IB, and next here HOC is connected. So this is the hybrid equivalent of the transistor. So along with this, we are also having the potential divider network consists of R1 and R2. So I am taking that R1 and R2 here, R1, R2, and also we are having the source resistance RS and the input signal Vs across the input side, and similarly across the output side we are having the emitter resistance RE as well as the load resistance RL is given. So here we'll measure the output voltage V0, and here the emitter current is flowing, and here the base current will be flowing here. And if you want to measure the input impedance, so this is the input voltage VB. So from here we can measure the input resistance. Okay, input resistance RA. If you want to find the overall input impedance, that is RA dash. So this is RA from only the hybrid model. RA dash is the for overall amplifier. And similarly, R0 is the output impedance of the hybrid model, and R0 dash is the overall output impedance of the amplifier circuit here. So this is the equivalent circuit. Okay. So from the common collector amplifier, we have drawn the equivalent circuit, and next we will do the conversion parameters so that we can able to find all the amplifier parameters here. So the conversion formulas. So the conversion formulas, first I am taking the input impedance HIC is equal to HI only. So that is 1 kilo ohm given in the problem itself, and HRC is equal to HRE, that is approximately equal to 1 here, and HFC is equal to minus of 1 plus HFE. That is nothing but minus of 1 plus 50 here it is. That value is minus 51. And next HOC, output admittance, is equal to HOE, that is given as 2 microamps per ohms. So these are the conversion values here. These values only we are going to utilize to find the amplifier parameters. So next we'll find the first amplifier parameter, that is current gain AI is equal to minus IC by IB here. Sorry, IE by IB here. Why? Because emitter current is the output current, base current is the input current in the common collector configuration. So this one we can write it as minus HFC by 1 plus HOC into RL dash. So here we know the value of HFC as well as HOC, but we don't know the value of RL dash here. So RL dash is nothing but the overall output impedance, that is emitter resistance parallel with the load resistance. That is nothing but here. These two resistors parallel combination is the RL dash value here. So here emitter resistance value is given it as 5.6 kilo ohms and the load resistance value is 47 kilo ohms. So again it is 5.6 into 10 power 3 plus 47 into 10 power 3. So if we simplify this one, we will get it as approximately 5 kilo ohms RL dash. Okay, approximately it is 5 kilo ohms. So now substitute all the values here. So minus HFC value is minus of minus 86. We have calculated. Oh, sorry, here this value is 80. So here it is 81, not 51. Here it is. So HFE value given in the problem is 85. So it is minus 86. So minus of minus 86 divided by 1 plus HOC is 2 micro amperes per ohms into RL dash is 5 kilo ohms. So if we simplify this, we will get it as 76.44 as the current gain. Okay, 76.44 is the current gain of this given amplifier circuit. In the second parameter, we are going to calculate here it is input resistance. Input resistance Ri. So the formula for this is HFC, sorry, HIC plus HRC into AI into RL dash here. So if we substitute the values here, HIC is 1 kilo ohm, HRE is 1, current gain just now we have calculated 76.44 and RL dash is 5 kilo ohms. Okay, if we simplify it, we will get it as 383.2 kilo ohms. Okay, so if we find the overall input impedance RA dash, so that is the parallel combination of source resistance as well as R1 resistance as well as R2 resistance here. So the source resistance value is 38.32 kilo ohms parallel with 27 kilo ohms parallel with again 27 kilo ohms. Why? Because R1 and R2 both are 27 kilo ohms. So if we calculate this one, we will get it as 13.04 kilo ohms as the overall input impedance of the amplifier circuit. Okay, and next parameter we need to calculate here it is voltage gain. Voltage gain AV. So voltage gain AV equal to current gain into load resistance by input resistance. Okay, so here RL dash overall resistance we need to take. So AA value is 76.44. We have already calculated into RL dash is 5 kilo ohms and RA is 383.2 into 10 power 3. So after simplification, we will get it as 0.997. So this is the voltage gain of the amplifier circuit. And if you wanted to find the overall voltage gain, so to find the overall voltage gain, AVS, that is equal to V0 by Vs here. So this one we can write it as V0 by Vs and multiply and divide it with base voltage VB. So that we can write it as V0 by VB into VB by Vs here. So here V0 by VB is nothing but the output voltage by input voltage, that is the voltage gain. So AVS is equal to AV into VB by Vs here. So we have to find VB by Vs value, where VB by Vs is equal to Ri dash by Ri dash plus Rs. So how we are writing this one means from the input side of the circuit. From the input side of the circuit, we are having the source resistance as well as the overall impedance Ri dash. So this is connected to the source voltage Vs. So here VB is flowing. So if we write the VB voltage, we will get it as Vs into Ra dash by Rs plus Ra dash by using the voltage division rule here. Okay, so AVS is equal to AV into Ra dash by Ra dash plus Rs. So substitute the values here. 0.997 is the voltage gain and Ra dash is the 13.04 kilo ohms. 13.04 kilo ohms plus source resistance is 600 ohms. So if we simplify this, we will get it as 0.953. This is the overall voltage. And next, we need to find the overall current gain. So to find the overall current gain, AIS is equal to, we can write it as IL by IS. So this one, we can write it as IL by IS into IB by IB. Okay, so this thing we can write it as IL by IB into IB by IS. So here IL by IB is nothing but the, IL by IE is nothing but the current gain. So IB by IS we need to find out here. So to find IB by IS, again I am taking the output side circuit, that is we are having the emitter resistance as well as the load resistance values. So here the emitter current is flowing in this direction but the load current is flowing in this direction. So the load current IL is equal to minus IE into RE divided by total resistance RE plus R. So if we substitute the values of these resistances here, we will get it as IL by IE equal to minus of RE by RE plus RL. Okay, so now here this IL by IE value is minus 5.6 into 10 power 3, that is RE value, and minus 5.6 into 10 power 3 plus 47 kilo ohms. So if we calculate this, we will get it as 0.106 here. Okay, and next if you find the IB by IS term. So to find the IB by IS term, we will get it as RB by RB plus RA from the previous circuit. RB by RB plus RA circuit here. AIS equal to AI into IB by IS value is RB by RB plus RA here. So if we substitute all the values of this one, we will get it as 7.754. This is the overall current gain. Okay, overall current gain. And next parameter we need to calculate here, it is output resistance. Output resistance R0. So to calculate this, we have to utilize 1 by HOC minus HFC into HRC by HIC plus RS dash here. So to find the RS dash, that is the input impedance, that is RS parallel with R1 parallel with R2, we have already calculated this one as 57.4 ohms RS dash value. So substitute all the values here. 1 by HOC value is 2 into 10 power minus 6 and forward current gain HFC is minus 86 and HRC value is 1 and HIC value is 1000 ohms plus RS dash is 57.4 here. Okay, after simplification, we will get R0 as 18.31 ohms. And to find the overall output impedance, R0 dash. So that is the parallel combination of R0 as well as RL dash. Okay, so if we substitute the R0 value as well as RL dash value, that is 18.31 parallel with 5 kilo ohms. We will get it as 18.24 ohms. So the overall output impedance is 18.24 ohms. So in this way, we need to calculate all the parameters from the given H parameters. So while coming to the second problem, a bipolar junction transistor with given values HIE, input impedance is 1100 ohms, and the forward current gain HFE is 50, and the reverse voltage gain HRE equal to 2.4 into 10 power minus 4, and the output admittance HOE equal to 25 microamps per ohms, and this is to drive a load of load resistance RL equal to 10 kilo ohms, and the source resistance is 1 kilo ohm here. In emitter follower arrangement, emitter follower arrangement is nothing but the common collector configuration only. Why? Because the output terminal is the emitter terminal here. Okay, and here we need to find the parameters of current gain, input impedance, voltage gain, as well as the output impedance of the given emitter follower circuit or common collector amplifier here. So before calculating the values, first of all, we have to do the conversion of H parameters into common collector configuration. That is, HIC is equal to HIE. So HIE value given it is 1100 ohms. And next, HRC, reverse voltage gain, is 1 minus HRE, that is approximately equal to 1 here it is. Why? Because HRE value is less than 1. And HFC is minus of 1 plus HFE here. So the HFE value is 50. So minus of 1 plus 50 is minus 51. And next, the output admittance is equal to output admittance in the common emitter configuration. So the value is 25 microamps per ohms here. So now we will calculate the asked parameters from the given H parameters. So the first thing we need to calculate here it is current gain AI, that is equal to minus HFC by 1 plus HOC into RL here. So here minus, it is 51. So minus of minus here. 1 plus HOC value is 24 into 10 power minus 6, and to load resistance is 10 kilo ohms. 10 into 10 power 3. So if we simplify this, we will get it as 41.13. So this is the current gain here. And next, we need to find the input resistance RA. That is equal to HIC plus HRC AI into RL here. So HIC value is 1100 plus HRC value is 1 here, and current gain just now we have calculated 41.13, and the load resistance is 10 kilo ohms. That is 412.42 kilo ohms. That is the input impedance. And next, to find the voltage gain, the next parameter is voltage gain. AV is equal to current gain into load resistance by input resistance. So The current again we have calculated 41.13 and the load resistance is 10 kilo ohms and the input impedance is 412.4 into 10 power 3 here. So after simplification we will get it as 0.997. So voltage gain of the given circuit here. So we're coming to the next problem. Draw the small signal equivalent circuit of emitter follower. So here emitter follower is nothing but again common collector circuit. We have to draw the small signal equivalent circuit of the common collector configuration by using the given H parameters as well as circuit elements. Okay. For the emitter follower circuit with source resistance this much and the load resistance is 5 kilo ohms, calculate all the amplifier parameters, current gain, voltage gain, input output impedances and assume the H parameter values, forward current gain 50 and the input impedance is 1 kilo ohm, output admittance is 25 microamps per volts and the reverse voltage gain is 2.4 into 10 power minus 4. So we need to find the current gain, input impedance, output impedance as well as voltage gain here. So before calculating these values, first of all we have to draw the small signal equivalent circuit of the given common collector circuit. So for that I am taking the three terminals of the transistor, base, emitter and collector here. Why? Because common collector, so that's why collector I am taking here it as the common terminal. So for this, so here we are having HIC, this is HRC, VCE and here it is HFC, IB and here it is HOC. Okay, and along with this we are also having the circuit elements, that is the source resistance RS and the input signal VS and here it is we are having the load resistance RL and here we'll measure the output voltage V0. So here emitter current is flowing and here the base current is flowing here and here the load current in opposite direction it is flowing. So along with this we require the conversion of H parameters into common collector configuration. So that is HIC, HRC, HFCI, HOC values we require. So here the input impedance in the common collector as well as in the common emitter is same. So the value is 1 kilo ohm and HRC value is 1 because HFE value is very less than 1 and HRE value is very less than 1 and HFC value is minus of 1 plus HFE. So HFE value is 50 is given, so minus of 1 plus 50 is minus 51 and HOE value is nothing but the output admittance in common collector is equal to the output admittance in the common emitter configuration, that value is 25 micro amps per volts here. So now we'll calculate the asked parameters in the problem. Okay, the first parameter is voltage gain. First we need to calculate the current gain value. So current gain AI equal to minus HFC by 1 plus HOC into RL here. Okay, so here substitute the values, minus of minus 51 divided by 1 plus 25 into 10 power minus 6 into 5 kilo ohms. So it is 205.33 current gain. And the next parameter is input resistance. Input resistance Ri is equal to HIC plus HRC into AI into RL. So that is 1000 plus HRC value is 1 and the current gain value is 205.33 into 5 kilo ohms. So after simplification, we will get it as 227.65 kilo ohms. This is the input impedance. And the next parameter we need to calculate here, it is voltage gain AV, that is equal to current gain into load resistance by input impedance. So the current gain we have calculated here it as 205.33 and the load resistance value is 5 kilo ohms and the input impedance is 227.65 kilo ohms. So after simplification, we will get this value as 0.995. And the last parameter is the output impedance. Output impedance R0 equal to 1 by HOC minus HFC HRC divided by HIC into source resistance RS. So after substituting all these values, we will get it as 29.41 ohms as the output resistance. So in this way, we need to calculate all the common collector amplifier parameters from the given H parameters as well as circuit elements. So in this session, we have seen two different kind of problems here. One thing is from the given circuit elements, how to draw the equivalent circuit of the common collector configuration, that is hybrid equivalent circuit. And after that, how to find the parameters or amplifier parameters by using the given hybrid equivalent parameters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.